In this video of the Greek case study, we will explore the basic skills for working with GIS. How to create a project and check its properties, as well as how to add raster and vector layers and check their properties. Let's start the exercise by creating a QGIS project. QGIS can be started like any other application on your computer. This means that you can launch QGIS by double-clicking the icon in your Applications folder. By opening the QGIS software, you have effectively created a new project. In any case, if you want to create another project from scratch, you can select Project, New, or just click on the relevant button from the project toolbar. An important issue when working with QGIS is the language of its interface. When QGIS is installed, it recognizes the operating system language and usually configures its interface in the corresponding local language. However, this course will cover the various QGIS tools and settings as listed in American English, so you must change the language of QGIS interface to American English. To do so, head to Settings, Options, General, and navigate to the first section. Then, make sure to tick Override System Locale option, select American English and click OK. You may need to restart QGIS for the change to take effect, meaning to close QGIS and open it again. You should frequently save your project to prevent missing any unsaved changes. You can save your project by selecting Project, Save, or by choosing the relevant option from the project toolbar. For the Greek case study, we will save our project with the name Greek Case Study in the path, C, MOOC MINERVA, Case Studies, Greek, Lab Greek. If you do not have this folder, you should create it. An issue that you should take into consideration when working in GIS software is the directory that you will save the project. Because QGIS and GIS software in general do not fully support non-Latin characters, for example Greek alphabet, resulting in incompatibilities in case the full file name contains non-Latin characters. Therefore, the full file names of your project and datasets, meaning the path and the name, should not contain non-Latin characters. Preferably, also avoid spaces, dashes, and other special characters, for example, full stops, semicolons, question mark, etc. Remember that if you do not indicate a specific folder for saving your project, the software will save it by default in another folder. The next step for our exercise is to check the properties of our new project to ensure that our exercise will run smoothly. We can do so by selecting Project and click on Properties on the expanding menu, and click on CRS tab on the left menu. Coordinate Reference System, or CRS in its abbreviation, is a coordinate-based local, regional, or global system used to locate geographical entities. Reference system defines the specific map projection, as well as transformations between different reference systems. In QGIS, Coordinate Reference System is usually indicated by the EPSG code. The EPSG codes are 4 or 5-digit numbers indicating the Coordinate Reference System, derived by the European Petroleum Survey Group. As we can see in the bottom right corner of our QGIS project, the default Coordinate Reference System is WGS84, or an EPSG code, 4326. As a result, the coordinates are expressed in degrees. Since we will work on Greek data, we will need to change the Coordinate Reference System to the Greek National Coordinate System. In the filter search, type Greek grid, and you can see that the GGR87 Greek grid coordinate system appears. We select it and click Apply and OK. Now we can see that the Coordinate Reference System in the bottom right has been changed in EPSG 2100 and the coordinates are now expressed in meters. Furthermore, in the bottom of the QGIS project, you can see the scale of your project. Of course, you can set a specific scale by typing your desired scale in the bottom of your project, or select a predefined scale from the expanding list in the bottom of your project. Moving to the next task of the Greek case study, we will explore how you can add vector and raster layers in QGIS project. The process of exploiting data with geographic meaning is the core of GIS. Whether we are studying a historic map or exploring the mapped historic traces of a city, for example, an ancient wall, GIS can help us visualize, analyze, and understand the geographical context, thus the space as a whole. First, we will add some raster data. Raster data could be easily understood as georeferenced images. For example, a historic map, an aerial photo, a satellite image. For adding a raster dataset in the QGIS project, select Layer, Add Raster Layer, or just select the corresponding option from the Manage Layers toolbar. Click the three dots to navigate to your File Explorer and go to the folder where your data are stored in the path. See MOOC MINERVA, Case Studies, Greek, Lab Greek, Raw Data. If you need, you can click on the drop-down on the right to select the option, All Supported Files, or the specific format of your raster data, specifically GeoTIFF for the Greek case study, to filter only the relevant files in your folder. There you can find the Kaupert GeoRef TIFF file and the VLSO Low TIFF file. Select them with Control and add them in your project. The raster data that we have added is a georeferenced historic map of the Western Hills of Athens and an aerial photo of the site. Now, we will add some vector data that represent the ancient remains and the ancient cisterns found in the Western Hills of Athens. For adding vector data in a QGIS project, select Layer, Add Vector Layer, or just select the corresponding option from the Manage Layers toolbar. Click the three dots to navigate to your File Explorer and browse in the path where all data are stored. See MOOC MINERVA, Case Studies, Greek, Lab Greek, Raw Data. If needed, you can click on the drop-down on the right to select the option, All Supported Files, or the specific format of your vector data, specifically ESRI shapefiles for the Greek case study, to filter only the relevant files in your folder. Select the Ancient Remains shapefile and the Ancient Remains Cisterns Points shapefile and add them in your project. Vector data are an important source of geospatial information. They could be easily understood as geometry features, meaning points, lines and polygons, accompanied with an attribute table containing information for the features. Remember to save your project to prevent missing any unsaved changes. After adding a layer in your project, you can examine its properties with right-click on this layer and selecting Properties. Some of the most important properties of your layer can be seen in the Source tab. There you can find the layer name, meaning how it is displayed in your QGIS project. Also, the data source encoding option is visible here, which is very important when working with features with non-Latin alphabet like Greek. If you open an attribute table and it is not readable, it is very likely that is due to encoding, and you should try to change the encoding. Suitable data encoding for the Greek alphabet is UTF-8. Other options are Windows 1253 and ISO 8859-7. If you encounter any issues with the encoding, you should be careful not to edit the layer before repairing the encoding issues. Furthermore, the assigned coordinate reference system is accessible here, which is especially important to ensure that the data are depicted properly in the space. In the next video of the Greek case study, we will explore the descriptive and geographical characteristics of our data by exploring the attribute table and the map accordingly. Additionally, we will see how we can select and export specific features of our data, as well as how we can create a simple map with our QGIS project.